Hi everyone. Today we are going to discuss about the special concrete, the module 3. Special concrete is a type of the concrete that is specially designed for the, to achieve the specific strength you want to require or specific performance you want to require when compared to normal concrete cannot be provided. So normal concrete not able to provide these certain properties, okay, below the properties. So in that situation, if you want, we can go for the special concrete. Example for a special concrete is a polymer concrete, sulfur insulated concrete, high performance concrete and high strength concrete and geopolymer concrete. These are the small example for your industrial you're using for a special concrete. And other recently the environmental sustainability also we have started to using the industrial wastes. During the concrete itself, so many industrial wastes are there that we are going to incorporate into our concrete that we are going to make it as structures. So these call for a special concrete. So that topic we are going to discuss about the module 3. Quick recap what we have discussed in the module 1 and module 2. So module 1, maintenance and repair strategies we have discussed it in earlier for basic definition of the what is mean by maintenance, repair and rehabilitation of the structures, and importance and facts of the maintenance, various inspection for the concrete structures, various assessment procedure to evaluating the existing structures, and various causes of the deterioration, how we are going to make a secure for the concrete that we discussed in the module 1. In module 2, serviceability and durability of the concrete. There we have discussed about the quality assurance for the concrete, how we need to maintain the quality assurance pre-construction days, during the construction, after the construction, how we are going to make as a concrete as a good quality. Then we have discussed about the strength and durability of the concrete, various tests to assess the strength of the concrete. For example, a compression test, tension test, and a flexural test to achieve the strength of the concrete. And discuss about the various durability of the test we are conducted. And what is the causes of the cracks, and how we are going to take the remedial action to rectify those type of the cracks. And finally, we discuss about the effect of the climate and temperatures on the concrete. So these all the discussed about the module 3. Now, new module called module 3, we are going to discuss about the special concrete. There we are going to discuss about the polymer concrete, sulfur infiltrated concrete, fiber reinforcement plastic concrete, and then high strength concrete and high performance concrete, and self compacting concrete, geopolymer concrete, and then concrete made with the industrial waste. So these all included in the module 3. We are going to discuss about the elaborating for module 3 for in this session. What is the core this module 2 objective? Learner to understand the why need for the special concrete compared to the conventional concrete and importance of the concrete. Why we need advanced concrete material or advanced concrete, special concrete when compared to the conventional concrete. What is the advantages and major applications for using the special concrete? So second objective to learn the different types of the special concrete. So already we have discussed what are the types of the special concrete: polymer, fiber reinforced concrete, self-compacting concrete, geopolymer concrete, high performance concrete, high strength concrete, geopolymer concrete. So these are all the different types of the concretes. Here we are going to discuss about the what is the properties of the special type of the concrete and advantages and disadvantages of the special concretes. Then third objective, the learner to study the difference between the high strength and high performance concrete. There we are going to discuss about the various properties incorporated in the high strength concrete and high performance concrete, and what is the benefit of both high performance and high strength concrete. So finally, we are going to know about the sustainable concrete using the industrial wastes. For example, fly ash, slag, and other demogenous concrete structures. So these are the wastes material that we are going to incorporate in our concrete to make as a structure. That is called the industrial waste of concrete. When you are using those type of the concrete, what is the environmental benefits of the sustainable concrete using the industrial waste? So these are the main objective of the module 3. Okay. So when you are talking about the what is the special concrete, The special concrete refers the concrete designed to meet the specific engineering requirement. If I want to construct the underground water construction, I want to make a huge bridge construction. Those time we cannot able to use for our normal concrete. For those environmental, we need for the special requirement of the concrete. Those type of the concrete is called the special concrete. Okay, meet the specific engineering requirements beyond the conventional concrete. Okay, that is called for special concrete. What is it need to enhance the strength, to enhance the durability, to enhance the workability or environmental condition? We need to go for the special concrete when we are not using the cannot able to give the betterment properties of the for normal concrete. We can go for the special concrete. Okay, for that, first concrete, special concrete is a polymer concrete. What is a polymer concrete? It's a composite material. That composite material is more than one material is called for the composite material. So in this polymer concrete, we are removing the our traditional binding material like a cement. So totally we are avoiding the cement. Instead of that, we are going to use for polymer resin. Okay. Now is a resin, polymer resin. It is a material, binding material. Instead of the cement, we are going to use. When you are using the polymer resin, what is going to happen? We'll get for superior strength. Compressive strength will get the more when compared to the normal concrete. We'll get for chemical resistance. So we can be able to use this type of the concrete for industrial purposes. And when compared to the conventional concrete, the durability also will be increases. So these are the things we get advantages for when you're using the polymer concrete. So polymer is a resin, is a very thick sticky fluid. After pouring the concrete, after hardens, what will happen? A normal concrete we having get the porous. Okay. So this porous it will help to the moisture can able to penetrate in the concrete surface. When you are going to start using the polymer concrete, the voice, the porous will be arrested. So moisture, the water cannot able to penetrate inside the concrete. Okay. So that is why saying that is a thick or a sticky fluid hardens permanently when left out the open air at a certain period of the time. After pouring the concrete, we need to show the exposure to the atmosphere. Automatically, it will be set quickly. So in normal concrete, when your water dries out, the pores, okay, that becomes a entry of the various liquid or gases. No? But what will happen in allowing to the air and water, automatically the damage will happen for the concrete. So when you're using this polymer resin, this is going to fill for our porous and wood. So automatically durability will be increases. Okay. So the composition of the polymer concrete, so we can able to use the different type of the binder. Epoxy, polystyrene, and vinyl ester, acrylic resin. These are the common binder we are using for the polymer concrete. When talking about the aggregate, sand, gravel, or crushed stone or quartz, we can use for the aggregate. Apart from that, filler additives, silica fume, fly ash, plasticizer, wherever when you want the additional properties to enhance the strength of the properties, you can able to go for different additives. Okay. In polymer concrete also, we having three different types of will be there. First one for a polymer concrete. So resin completely replace the cement. So 100% we are not using the cement. So totally we are using for resin for binder material. And second one, the polymer cement concrete is the name itself. Polymer is added to the cement to improve the performance. Okay, so we have based on the performance, based on the requirement, we can able to use the percentage of the polymer we are adding for the cement. Third one, polymer impregnated concrete. The concrete will be hardened. Okay, then is infused with a monomer. We can able to use a different type of the monomer. In this monomer, we are going to use it for hardened concrete. Okay, that is called polymer impregnated concrete. What is the difference between the normal concrete, that means traditional concrete, as well as the our polymer concrete? When you're taking about the composition, when you polymer normal, our conventional concrete will take for 22 megapascal. When you're using for the polymer concrete, it will take for minimum of 70 to 140 megapascal. The huge compressive strength will come when you're using for the or polymer concrete. Tensile strength, normal conventional concrete is 2 to 5 megapascal, but when you're using the polymer concrete, 10 to 20 megapascal it will come. So water absorption is high in conventional concrete, 5 to 10%, but this is for polymer concrete concrete less than the 1%. What is the main advantage of when using the polymer resin? This resin going to penetrate, it will fill for the voids of the entire concrete structure. That's why we saying less than 1% of the water absorption will be happen. What is chemical resistance? So when you're using the conventional concrete, whatever may be chemical adding also, there is a moderate chemical resistance for the conventional concrete. Okay, it's lower than the conventional, it be concrete. So density will be higher in conventional concrete, it be lower. So few hours will be, then operate it will be edge. So curing time, it will mainly conventional concrete 28 days, but it will be within a few hours it will take. So moderate durability here, when you're using the polymer concrete, it will be very high durability it will get. Okay. So majority, all the properties when compared to the traditional metal, polymer concrete will be very high. Okay. So he having a different polymer concrete will be there based on the resin what we are using for binding materials. When you saying the polymer cement concrete, okay, in this polymer cement concrete, we can able to use for aggregate resin. One type of resin we are going to use as a binding material. So when you're using this type of resin, automatically improve the durability of the structure. Tensile strength will be increasing when compared to the conventional concrete, where a very good adhesion for the properties. Okay, these are the things for advantages of when you are using the aggregation. Here also having a disadvantage is very cost. Yes, of course, we need to procure and what we need for the skilled person. For that, we need for the good workmanship people. So cost will be high. So precise mix is required. In conventional, we know the M20 or M20 we can able to go, but we need to precise special mix design is required for the polymer concrete. Now, where we are going to use this type of the concrete for industrial flooring, where we need for industrial, for that wear and tear and chemical resistance, so increase in durability and strength, because machine and everything we are going to floor in above the floor. For that, we can use for this type of the concrete and pre-stressed concrete and the sewer lining. That because and sewer having a more pH value and more chemical in that, so days going on, automatically erosion will be or wear will come for the inside wear pipelines. So we need to resistant. For that, we can go for the polymer concrete. And second one, polymer impregnated concretes, here we are going to use for epoxy resin of the binder materials. Now using epoxy resin is a very high durable and high strength we can able to attain. We can resistant for the abrasion distance. But disadvantage, if you're talking for the polymer impregnated concrete, it will be a very complex and a costly process to make for those type of the concrete. Okay, so where we can able to use this type of the concrete in bridge deck, hydraulic structure, and the sewer line. So there we can able to use for this type of the epoxy resin for in polymer impregnated concrete. So polymer concrete, polystyrene is the resin we are using to make a structure. Very fast hardening when compared to the other resin. Very high strength we can able to attain. It will be very corrosion resistant. So where you are getting the corrosion will occur, there we can able to use for polystyrene resin. So what is the disadvantage? Is the resin will be shrinkage very easily when you're handling the toxic fumes. With the inhaling of the people, it is very difficult. This is the type of the resin we can able to use for chemical plants, sanitary structures, and visual foundation. We can able to use this type of the concrete. Okay. The polymer modified is concrete. The polymer we are going to modify certain adding for the stain for resin. Improved adhesion, then excellent waterproofing of the materials get and freezing thawing resistance where having a fluid, more cold climate, no more less than minus 20 degrees Celsius. There we can able to use for this type of the resin. What is the disadvantage? Maybe causes for the shrinkage, require proper curing. When compared to the other things, we can able to use for repair works and protective coatings and road pavement works. Okay, so this is a different type of the polymer concrete, different resins we are using. We have discussed about what is properties and what is advantages and disadvantages where application of the using for the various polymer concrete. So next, special concrete is important word. Special sulfur infiltrated concrete. It is a type of modified big concrete where the molten sulfur usually fills in the pores of hardened concrete. Yes, already hardened concrete is will be there. In normal hardened concrete, having a pores and voids will be there. What we are going to do, we are sulfur, we are going to molten. But molten sulfur, we are going to pour entire the surfaces. This sulfur going to travel and close and arrest for the pores. Automatically, our durability will be increases. So this process significantly improve the strength and impermeability cannot able to enter the water. That means less than 1% of the absorption will be there. And the chemical resistant when compared to the conventional concrete. Why we need to use the sulfur? Sulfur fill the voids. Okay, hardened concrete, if you're using the sulfur, it will be filling the voids in the concrete and making the concrete to be more denser. It bonds well and cement and aggregate and steel are getting more bond within a cement matrix. So automatically, it's a bond good mean automatically increasing the strength will be. So it's provide the chemical resistance to making the deal for the aggressive environment. So what is how to process for the sulfur infiltrated concrete to make the porous of the concrete? Because normally using the conventional concrete definitely be above the surface having a porous and different voids. Okay, then what we need to do? We need to heat the concrete 250 to 300 Fahrenheit centigrade and melt pure the sulfur separately. The hardened concrete one stage and other stage will be there and sulfate should be purely separately. Then pour molten sulfur, fill the voids heated concrete. Okay, this concrete we need to pour automatically should be travel and going to close. Okay, all the cracks. Okay, what is the properties and compared to the conventional concrete, the compression strength will be increased from the 55 to 80 megapascal. Okay, very low permeability and high density for the sulfur infiltrated concrete. So advantages: high listed rapid curing in a minute. In a minute, it started to curing. Excellent durability and chemical resistant, co-effective upgradation of the interior will be concretes. Where we can be able to use this type of the sulfur insulated concrete, industrial flooring, bridge deck, water tank, and a foundation block we can able to use for sulfur insulated concretes. What is the disadvantages? It will be high temperature exposure because both, it will be conventional concrete as well as the sulfur also we started to heating. Okay, then we get the more high temperature exposure. Sulfur leaching, there will be losses, and micro cracking or shrinkage will be over period of time, it will be hacked. Then using the sulfur infiltrated concrete, what are the smell will be occur for that or inhaling. இன்னைக்கு அதிசயமா இருக்குது பறக்குது இந்த சவுண்ட் வருமானா so it'll be when we started to smelling, no, it will be respiratory problem will come for the using for sulfur. Next one is fiber reinforced concrete. Now, what is a fiber reinforced concrete? It's a normal concrete mixed with different type of the fiber. Okay. What you call different type of the fiber? We can use for the steel fiber, or we can use for the glass fiber, synthetic fiber, carbon fiber. Okay, and different type of the natural fiber also will be available. So during the mix, manufacturing of the concrete, we can able to use for different type of the fiber based on their requirement. Okay. So what we need to, because why we need to use for this type of the fiber to improve the tensile strength and control the cracks. Even micro cracks also we can able to control for using the different type of the fiber. It's a more durable and impact the more resistance. Okay, so these are the pictures shows the different type of the fiber: steel, glass, synthetic, carbon. We have in different type of the natural fiber also will be there: coconut fiber, bamboo fiber, jute fiber, sisal fiber. These are the natural fiber we can able to mix in our conventional concrete to get the performance strength of the concrete. When you start using the steel fiber to improve the crack resistance, tensile strength also be increasing, and erosion resistance also be increasing when using the steel concrete fibers. Using the glass fiber concrete, this is lightweight, more flexible when compared to the other concrete, to increasing the impact resistance, and you are using it for glass fiber reinforced concrete. Using the carbon fiber reinforced concrete is a very high strength to weight ratio. Excellent fatigue resistance will be non-corrosive. So repairing work and strengthening of the structure, especially for seismic resistance of the structure, we can go for the carbon fiber concrete. It is very useful. Okay, and synthetic concrete, safe or non-corrosive. good for the plastic shrinkage concrete and more economical for using for synthetic fiber. Various natural fiber we have seen using the natural fiber is a more sustainable, more eco-friendly, it's more ductile, reduce the crack with cheap and lightweight. So these are the properties or advantage of using for the different type of the fiber reinforced concrete using for in conventional concrete. Next is high strength and high performance concrete. Both are important for our civil engineering work. What is the high strength concrete? Designed the concrete mix provide the exponential strength when compared to the normal strength of the concrete and performance compared to the normal strength of the concrete. So it is typically compressive strength exceeding the 40 megapascal and beyond for 100 megapascal also. In normal convention car, if you properly doing also will get for 50 megapascal. But when you're using for the HSC concrete, minimum is 40, it will go beyond for 40 megapascal also. What is a high performance concrete? Type of concrete where we need for the superior strength and durability and workability when compared to the normal concrete, we can go for the high performance concrete. There will be harsh condition of the environmental bridges in underground water construction, high rise building, and marine environmental, there we can use for the high performance concrete. What is the comparison between high performance concrete and high strength of the concrete? When you're using the high strength of concrete, we get for maximum of 60 megapascal and increase the compressive strength. So here HPC improve the ductility as well as the workability also. So properties in the high strength, low permeability, but it's a brittle material. Here it be HPC is durable, it's more easily to workable and chemical resistance. It's a manufacturing is low water cement ratio. Quality of the cement aggregate is very important. Here for high performance cut, we are using various superpacers are available and mineral admixtures also available in the market. There we need to use for performance to increase this. Okay. So when you're using the high strength of the concrete, reduce the member size of the thickness of the slab or beam or column. So automatically dead toll will be decreases. So here for excellent durability, it's a long service life for high performance. So main disadvantage is the brittle material. It will be easily break when compared to the other concrete. We need to maintain the proper quality control. Disadvantages for here, high cost and skill supervision will be required. Application for HSC, high-rise building and long span bridges we can able to use. Marine structure, bridges and water tank we can able to use for applications. Next one, self-concreting concrete. Name itself, it is self-compacting. When you started to pouring the concrete, automatically due to gravity, it started to flow the own weight. Okay, so no vibration is required. Automatically it will flow and excellent filling ability. All the places it will go and fill the atom. So resist is segregation, but in normal concrete segregation bleeding will be there. But here totally we are avoiding the segregation. Okay, so ideal for the congested reinforcement. In normal concrete, conventional concrete, during the convention congested reinforcement, we cannot be able to proper compaction. But here for self-forming concrete, is the main advantages is the congested reinforcement also we can able to pour concrete properly. And you see the self-compacting properties, it will be highly flowable, like a water is started to flow and automatically it will self-leveling. The fill dense reinforcement, all the areas easily fill, no need to vibrate like a or conventional concrete. Okay, so automatically it will improve the constructability advantages, reduce the labor and time costs also will be reduced, leave the smooth even the finish also, better filling for the complex forms. So best practice, we need a proper mixed design to make a self-competing concrete. So use the poly super process. Adequate testing and quality is also be required. Okay, what is the disadvantages? The high material cost will be required because we need to use for the various super plasticizer and viscosity modifier. Sometimes we need to use super fly ash and limestone. No? That so initial cost will be high. So very risk in the segregation and bleeding because it started to flow. So maybe chances are segregating or bleeding. Special quality control is be required when compared to the conventional concrete. So limited use of some courses aggregate also. We cannot able to use for high size of increased aggregate also. We cannot able to use this self-compacting concrete. We use for a high-rise building, more tough for building, bridge and flyovers or tunnels, precast elements, repairing work. We can able to for self-compacting concrete. Okay. Next special type of the concrete is geopolymer concrete. It's be eco-friendly concrete. The alternative for the conventional concrete uses for the various industrial byproducts. For the fly ash or slag, silica foam, or metakaolin. These are the industrial byproducts. This we can able to use for the in concrete cement. So it will be activated with alkaline solution such as sodium hydroxide and sodium silicate, forming a strong and durable binder for the geopolymer concrete. So what is the properties of the geopolymer? It's environmental friendly geopolymer concrete activated by the alkaline solution, low sinkage and low heat of the materials. Okay. Advantages talking about the geopolymer concrete, the great durability and the fire resistance. So utilize the various waste materials, low CO2 emission and high strength of the concrete. So these are the material we can use for the geopolymer concrete, fly ash, slag and aggregate. Okay, that's we can able to use. Okay, when you see the properties, high flow level and self leveling, be activated by the alkaline solution, low shrinkage and low heated. When seeing for disadvantages, slow setting time, need high to the curing temperature, high alkaline requires care, and limited data on long-term properties. Where we can able to use geopolymer road and pavements and bridges and marine structure, we can able to use for the geopolymer concrete. Next to special concrete, the concrete made with the industrial waste. Okay, what is the industrial waste? By waste, no, after using of the materials that we are going to dump in other materials, that wastes we are going to include for the in our normal concrete. Okay. When using for the industrial waste in the concrete, automatically improve the sustainability and reduce the cement usages and utilize it by products also. So normally, commonly using different type of the industrial wastes, fly ash, DGBS, silica fume, recycle aggregators, rices, ash, and plastic wastes. No, these are the things we can able to add in the concrete to increasing the performance of the concrete. That is what for the concrete is made for industrial waste. Industrial wastes. It's a sustainable concrete mix where the industrial byproducts such as fly ash, DGBS, silica fume, recycled aggregate, rice as plastic waste are used partially, fully replace the traditional cement natural aggregates. So this is a reduce the environmental impact and improve the durability and performance of the concrete. Concrete made with the industrial waste, we can use for fly ash. When using the fly ash, automatically improve the workability and enhance the workability. If using the GGBS, increasing the strength of the concrete and reduce the porosity also. Now using the ground granular ballast furnace, the slag material, so increase the strength and reduce the porosity also. If using the silica fume, so increasing strength as well as reduce the porosity. Using the class waste automatically improve the sustainability and reusable for the aggregate. So recycle aggregate, no, whatever demolish in our concrete structure, we can able to use for recycle aggregate. It will be used for eco-friendly and reducing the waste. When using the raw material in industrial waste, is sustainable and eco-friendly also. More cost-effective solution, reduce the carbon footprint also. Advantages in using this type of the industrial waste is sustainable and eco-friendly, reduce the carbon footprint. Okay. What is the disadvantage for using this one? Variable quality of the wastes and potential contamination will be occur and need for a careful mixed design. Okay. Where we can able to use this type of the industrial waste concrete, making the road and pavement, masonry work, non-structural element, eco-friendly construction. Okay. So these are the application for using the concrete made mixes. So now, as I discussed, it's a mind map. What we discussed in the all these slides. Now we seen for the special concrete. What is a special concrete? It is also like a type of the concrete specially designed to achieve the specific performance or specific strength when normal cannot concrete cannot be provided, we can able to go and choose for the special concrete. These are the few examples we have seen for the special concrete. One is a polymer concrete. In the polymer concrete, we have seen improved durability and resistance to the corrosion. And sulfur inflated concrete, high strength and high stiffness, and increasing the durability when using the sulfur inflated concrete. Geopolymer, concrete with a high hold, we can using the fly ash or slag sustainable constructions. High performance concrete, superior strength and durability, we can go for high performance concrete and improve the workability. FRP, enhance the tensile strength of the concrete and reduce the cracking and improve the impact of the resistance. We have discussed about the self-compacting concrete, so no need to vibration, automatically self, it can able to flow and fill the voids, and high flowability for the self-compacting. Finally, we have discussed about the concrete made with a different industrial waste. It's a cost-effective solution and utilize the byproducts and the slag and environmental friendly. So this is discussed about in the module 3 for special concretes. So hope you all can understand the module 3. Especially for you can able to identify the major type of the special concrete and that the basic features of different type of the special concrete, like a polymer, fiber reinforced concrete, geopolymer concrete, high performance concrete and high concrete. These are the things you can able to easily identify. And what are the properties, the manufacturing process, advantages and disadvantages and application of this type of the special concrete, you can able to easily identify. Okay, then learner may can able to explain very easily a common application of the special concrete in the civil engineering work. Now you can able to compare the conventional concrete with a special concrete in terms of the performance and durability. So now you can able to recognize the role of the industrial waste material and producing the sustainable concrete. These are the module 3 outcomes. Okay, so as usual, we are started to reference 3 books as usual. We are maintaining the concrete structure production and repair and rehabilitation for Doug Woodson, and concrete structures repair and rehabilitation and retrofitting. This Bhattacharya G, and maintenance repair rehabilitation of retrofitting as structure, Dr. G. Nandini Devi. These are the reference book we are following for the is module 3. Okay, so this is only we discussed about the module 3 for special concretes. So very soon we are going to discuss about the module 4. We are going to see for the different topic we are going to discuss. So thank you for all once again passion for listening for the module 3. Thank you.